Okay, so when we learnt about measuring angles in radians, I said radians make a lot more sense than degrees because they make maths a lot cleaner. Here's our first example of where that's true. I don't know about you, but that's the degrees formula. That is the radians formula for calculating this length L here. I'd much rather use the radians formula. Looks a lot nicer. Same as this. That would be radians up the top, and that would be degrees down bottom there. I'll give an example of the area formula and how this sort of comes about. Or maybe I'll give an example of both. The circumference around a circle is 2 pi r. If that's r, the circumference is the whole length around. So if I have an angle theta, and I want to know the length, that length is 2 pi r times that angle out of, now in degrees it's 360 around a whole circle. So if we simplify that down a little bit, like a tiny bit, you can cancel off the 2 with the 360 to get 180 down there. So I mean, I guess it's pi r theta over 180, right? So that's a little bit nicer. So that formula there could actually simplify down a little bit. So that's all right. But if we do it in radians, it's a lot nicer. So that was degrees. Now, if we do this formula in radians, it's going to be much better. The length is 2 pi r times the angle out of, now, as we said when we learned radians, the whole way around a circle is 2 pi. So 2 pi is sort of like our 360 degrees. And that's in radians. So the 2 pi on the top and the 2 pi on the bottom will cancel. So you're literally just left with length is r theta. And if you repeat this same calculation for area of the sector is usually pi r squared times the angle out of 360. So nothing cancels off. You just get pi r squared theta over 360 gross. That's the area in degrees. And in radians, the area is the whole area, so pi r squared times the angle out of, and it's 2 pi to be the whole way around. So you get pi, we'll cancel off the top and the bottom. And so all you're left with is you get r squared theta over 2. Again, a much nicer formula for area. Okay, so let's apply it. A sector has a radius of 11 and an angle of 2 radians. So let's see, 2 radians would be something like that. No, I lied. 2 radians will be something like that. Because pi is a straight line, so 2 is just a bit shy of pi. There it goes. And that's got a radius of 11 centimeters. So find the arc length and area. So the length is going to be r theta. So that is 11 times 2. So that's 22 centimeters. And it's a length, so that's in centimeters. The area is r squared theta over, let me make sure I got this right, half r squared theta. So r squared theta over 2, if you like. So if we do that, then we've got, that's 11 squared times 2 over 2. In fact, they will just cancel off. So you're left with 11 squared. Done. Very easy calculations. If we did that in degrees, it would be much more difficult. A sector has an angle of pi over 4 radians. So by the way, that's about 45 degrees, pi over 4. And it's got an area of 2 pi meters squared. Find the radius. So we're just going to leave that as r there. Now, area is 2 pi. But area is also theta r squared over 2. And that just comes from that formula up there. Okay, so let's see if we can solve it. Theta was pi over 4. Maybe I'll times by 2 first. So I'm going to get theta r squared is 4 pi. Therefore, pi over 4 is theta. Yeah. If I times both sides by 4, I'm going to get pi r squared is 16 pi. And you can divide both sides by pi, which will essentially cancel them off. So you get r squared is 16. Therefore, r is plus or minus root 16. So r is plus or minus 4. And is that in centimeters? No, it's in meters. Okay, so that's good. But I don't know about you, but I've never seen a length of 4 meters, so negative 4 meters. So we're just going to go with positive 4 here, and something like lengths are positive. Wonderful, and we're done.